More fun with linear stuff. Again, whiteboard is active. So stuff is linear. We noticed that in a couple of different ways. In the beginning of the course, we looked at these classes of equations, linear, exponential, quadratic. And linear equations tend to look like y equals some number plus some other number, but we may use different numbers. So for example, we were playing around with BAC. We had b equals negative 0.015. We used a t instead of an x, plus 0.104. So anytime I have two variables, one variable is just a multiple and some number added on or subtracted, that's the idea of linear. Generally, we have some variable y or b on this side. That's called the dependent variable. Dependent, there we go, variable. And on the other side is our independent variable. Sometimes it's x, sometimes it's t, sometimes it's something else. So the x or the t in this case, this one, this one, this one, those are my dependent variables. I lied, independent variables. And they're called dependent independent for a couple of reasons. Variable, there we go. One reason is just the way we write them. We write the equation so that it's easy to plug in x. To then calculate y. So when we write equations this way, like y equals or b equals, the y value depends on what the x was, right? We pick an x, plug it in, that tells us y. So in other words, y depends on the x value we pick. So that's one reason we call them independent and dependent. I can pick any x I want, easily plug it in, make a calculation, figure out what y is. But sometimes it matters physically. So I had a couple of beers last night, and at first the alcohol in my bloodstream is pretty high. I feel the effect of those beers. But as time goes by, the alcohol is getting metabolized by my body, and the amount of alcohol noticeable in my bloodstream is decreasing over time. So the amount of alcohol in my bloodstream depends on the amount of time that has gone by. It doesn't go the other way. Time does not depend on how much alcohol is in my blood. Time keeps going. I cannot stop it. And so sometimes there's a physical reality choice to what variable gets to be independent and what gets to be dependent. And if we try to switch it, it doesn't make as much sense physically. So there's a couple of reasons why we call them independent and dependent. Other things here, variables versus constants. So I mentioned that my dependent variables in these cases, I'll choose a different color for that. How about yellow? My dependent variables were the y, the b, the y. Independent variables I had highlighted in blue, that was the x, the t, or the x. Those are my independent ones. So I can plug in different numbers for time, different numbers for x. I can even plug in different numbers for the BAC and then go back and figure out the time. Those things change. Constants are things in the equation that are fixed for that situation. So for example, in the BAC, I have a typo there. Let's fix the typo. Should be 0.015. This negative 0.015 persisted throughout the situation I was working on. So that 150-pound male, that number stayed still. That 150-pound male, this 0.104 stayed still for the whole problem. So those are constants in the problem. In the linear stuff, the kinds of constants we have, m is what we call our slope. It's also called a rate of change. We're going to spend a couple weeks talking about that. Why we call it a rate of change. And then that value b is often called the y-intercept. It's sometimes called the starting value. Or the initial value. And once we start a particular problem, there's going to be a fixed slope, there's going to be a fixed y-intercept, and then we have two other things that are going to change. And we'll look at a few examples of that today. So last class, time was changing and the BAC was changing, or maybe the number of drinks someone had was changing and their BAC was changing. Those would be variables which are different than our slope and our y-intercept. All right, so let's look at our lesson for today. Lesson 3.3. So there's an intro video here, recording of me talking to students in the past about this lesson. So check that out if you get stuck on this later. Otherwise, I'm going to do the same stuff right now. And here's the stuff we're working on. We're looking at these different situations where linear stuff pops up. It's mainly what we're focusing on. And the idea of slope, rates of change. So take the time to read through this later. I've talked about much of it. Here we have an example similar to what we did in previous class. We have a 150-pound male that had 3 drinks. And if you plug that all into the original BAC equation, you get an equation that looks like this one right here. And then we calculated down here a table, 0, 1, 2, 3 drinks. What's their BAC look like over time? And we can see if we graph those points, they line up quite nice. And so we played around with graphing those in the lesson before. So this is just a similar example reviewing what we did before. And we'll look at another one in just a moment. The idea of slope as a rate of change, a rate means things are divided, like miles per hour is a rate, right? The speed I drive my car, miles divided by hours, miles per hour. The rate at which the alcohol is metabolized in my blood is going to be percent BAC per hour. And there's lots of other rates out there whenever we do something. And the rate can be seen graphically as an increase or decrease in y followed by an increase or decrease in x, depending on the direction. Right? So we have an idea of what we call rise over run. And we're going to play with that over the next few weeks. The equation I wrote down earlier, the y equals mx plus b, we call that the slope-intercept equation for a line, because in it, I can clearly see what the slope is for the situation, and I can clearly see that intercept, that starting value in the situation. So I'm just going to go back and pick on the equation they just gave me. So the type of equation we're playing with for the next few weeks, y equals mx plus b. Instead of a y, we're using a b for this one. M negative 0.015. Instead of an x, we're going to use a t. And I usually put a little hook at the bottom of my t so I don't mess it up with my plus sign there. And then the b, thank you, tablet, we'll fix you in a minute, 0.083 for this person. This number right here is my slope. So slope, so we use the letter m for that, negative 0.015. Now, often we talk about slope as this idea of rise over run. You've probably seen that in a previous math class in your past life. Not rum, Gary, run. And the rise is our vertical change. And the run is our horizontal change graphically. Another way that it was talked about, if you look at the reading we had just a minute ago, is that rise is also the change in the output variable. Remember, output is our dependent variable. And then the run would be the change in the input, the way we write the equation. And the input is our independent variable. So this slope right here isn't given originally as a fraction, but I can always make it a fraction. I can take that negative 0. Oops, extra negative there. Negative 0.015. And just simply writing it over 1 would be one way to do it. I could get my pen and my hand to work together well. And then think about what was my input here and what was my output. So my output was B. So I have a change in BAC in the numerator. And my input variable, that's the denominator of this fraction, that would be my change in time. Time was in hours. That would be a change in hours. So this one right here would be a negative 0.015, that's the percent BAC, divided by a positive 1 hour. Negative can be viewed as a decrease or a drop. We looked at that in the other lesson. So what does this slope mean? Often I'm going to ask you to interpret these situations. So if I want to interpret the slope in words, we would say the BAC decreases or drops to deal with the negative by 0.015%. And I don't need to put the negative because the word decrease means negative. Each hour or per hour. Be a little more specific to deal with the 1. All right, so that's an interpretation of the slope. And remember, per means divide. Sometimes we use each instead. I like the word per better than each. So that'd be the interpretation of the slope. The y-intercept, what does that mean? That b is 0.083. Notice that's a lowercase b. That's our y-intercept. If we were to put a 0 in for t, 0 times anything is 0. 0 plus 0.083 is still 0.083. So a y-intercept, often called the initial value, is really a point. It's going to be the point 0 for the independent variable, and then whatever the number is, 0.083. So what does this tell me? 0 is hours, and the 0.083 is the percent BAC. And time is supposed to be after we started drinking. So let's suppose this person drank 3 beers in a couple of minutes. So right when they finish those beers and it gets into their bloodstream, their BAC is immediately 0.083. Now the time works a little bit different than that. So that at the beginning, the equation's a little bit sketchy. But essentially what this says is if a 150-pound male has 3 beers in succession pretty quick, then their BAC, initial BAC is going to be about 0.083, right? A little above the legal limit for operating a motor vehicle. So that's the initial value part. And we're going to keep talking about how to interpret those. Let's go back to the lesson. All right, so here I'm asked to write an equation of a line with a slope of 5 and a y-intercept of 0, 2. And I mentioned a moment ago, a y-intercept is a point. The b is the y value of that point. The x value is always 0. So for this one right here, they're telling me to use y and x, and they're reminding me in the toolbar here, y equals 5 is the slope, x plus 2 would be the equation for a line that has a slope of 5 and a y-intercept of a point 0, 2. Different situation, Terry is skiing down a steep hill. Terry's elevation, E, in feet after t seconds is given by E equals 2,600 minus 70 t. So let's break that down, see what that means, see if we can fill in the blanks here. All right, so we have the skiing equation. So E, elevation, in feet, there we go. T was seconds, I think. Double check that. Yep. And then the equation E equals 2,600 minus 70 t, and I'm going to rewrite that. I'm going to switch these two. Now, when you subtract a number, that's like adding the opposite. So the 70 is the negative thing. So I could also write this as E equals negative 70 times t plus 2,600. And I'm thinking about the y equals mx plus b thing. So this tells me the negative 70 is my slope, and the 2,600 is part of my y-intercept. So let's break that down. Slope, that rise over run. My rise is my elevation. My run is my time in seconds. So I want to rewrite the negative 70 as a fraction. And so the easy way to do that is negative 70 over 1. Elevation in feet. So that's negative 70 feet per 1 second. So the negative is a decrease. The 1 is a positive. So this tells me her elevation is dropping 70 feet per second. If it's a woman, is dropping or decreasing, whatever word you like there, 70 feet per 1 second. And so then your job is to fill in the blanks to describe what that means again. So I'm interpreting the slope here in that sense. The y-intercept, our starting value, initial value, starting point, is technically the point 0, 2,600. So x value, the t value, that's seconds, right, up here. This is feet. So this says she started at an elevation of 2,600 feet. So it's important for me, one of the goals in this class is that we can look at an equation and if somebody tells me what the variables mean, then I can break it down into words for someone, and my mom would get it, who doesn't do as much math as me. Or go the other way around. Somebody gives me a bunch of information about a situation, I can say, oh yeah, I can put that in an equation. Both of those take practice, and that's what this is about. Okay, so I'm gonna give you guys a minute to fill that out. If you have a question, just holler, and then we'll move on. So our next problem here is to try and graph that. So let's do it. So first equation, negative 1/2 x plus 2. And remind you, that's my slope. I think a slope is rise over run often. A bunch of other ways to describe it. And it is negative 1 over 2. So I have a negative 1 for the rise. So that's really a drop 1. And then the positive 2 means positive for x is right, 2. And then remember the 2 is our y-intercept. So b is our starting y of 2, which means I really have to point 0, 2. So to graph this, I don't even have to calculate points like we were doing before. I can just start off with a grid. So let's go 1, 2, 3, 4 maybe. 1, 2, 3, 4. And this is y, my dependent, x, my independent axis. So to graph this, I would start at the point 0, 2. And then to use the slope tells me to drop 1 and go right 2. So I should get a point right there. Drop 1, go right 2. Interesting thing about slope, negative 1/2 is the same thing as 1 over negative 2. And sometimes we put the negative in front, right? So a negative fraction I can view as just a negative fraction, or as a positive over a negative, or a negative over a positive. Now, if I take this second interpretation, this one means go up 1, And down here, and that's the run, negative would be left 2. So if I see what happens there, I guess I got to put a few more numbers on my grid. If that's 1, -1 would be here, -2 would be there. So from my starting point, I should be able to go up 1, left 2, which puts me about there. And you can see those points all line up pretty nice. If I had real graph paper, they'd line up better. Oh, I did good. Look at that. Sweet. For our graphing utility on the computer, we can only pick 2 points. So I would go with my default, which was start with the y-intercept and then use the slope to get a second point. And warning, you probably already know this, if you try to do this kind of problem on a phone or a tablet, it's a nightmare. At least I think it is. Computer's the easiest way. Let's say starting at 0, 2, go down 1, right 2. So that should be the graph of it. And again, this tool here, you can only use 2 points. So in my paper, I did more than 2 points. I can't use them here. I can only pick 2 points here. Yippee, I got it right. Okay. All right. Cool. Moving on. Next part. So here we have a situation, a fundraiser that we have to get through. We want to fill out a table of information about it. Based on that table, we're going to predict some more stuff, information about it, more information. We're going to try to make a graph based on the table. And then again, more information about that. So we're just going to keep on expanding this one. So we have a sports team is planning a fundraiser to help pay for equipment. Their plan is to sell team t-shirts to friends and family, and they hope to raise $500. Cool. Their local screen printing shop will charge them $75 for setup, $5 per t-shirt, and then they plan to sell the t-shirts. Okay, so right up front, they got to pay out $75, right? So that's a loss compared to the $500 they want. And then they have to pay upfront $5 a shirt, but then once they start selling them, they're going to start gaining $15 per shirt. And we are interested, the money they make, that's called profit. So let's try to summarize that. So we want to figure out what's their profit. And so far we know we have a one-time setup fee. So that's like a starting thing, right? Right in the beginning, they got to pay that. So that, I think, sounds like that setup is like a y-intercept. And then the slope is something that changes per hour, per t-shirt, something like that. And I do have a bunch of those. I got a $5 per shirt here, and I got a $15 each, which is another way to say per shirt. So they have to pay out these things here. So maybe I should have circled those in red, right? Pay out, pay out. Those are the costs of this situation. And then the $15 each shirt, right? That's money they get in, right? So they take that in. And when we take something in, that's called our revenue. Profit is always revenue minus cost, right? So thinking about the cost as being negative. So as far as my profit, right, money I want to make, I start off with a loss of 75. And then for every shirt I make, that's another loss of $5 per shirt. And let's say I'm going to just call the shirts X for now. So X is shirts. And I'm going to double check. They sometimes might want to use a different variable. Right, so starting off, I have to pay out $75, and then I have to pay out $5 per shirt. But then I gain $15 per shirt, right, for X shirts. So if I sold 100 shirts, that's 150 bucks. If I made 100 shirts, that's, sorry, not 150. If I sold 100, that would be $1,500. If I made 100, that would be $500 that it cost me, right? So when I put these two together, for each shirt, I lose 5, but gain 15, I net $10 per shirt, right? So that's my net, which is the profit. But always that 75 is out front. So this, I think, is going to be my profit. And I'm going to switch the order. I'm going to write it as 10x minus 75. The 10 is my slope. So as far as the profit is concerned, I'm going to get 10 over 1, which is $10 per each shirt. So that's the money I make. And then the y-intercept is if I sell no shirts, I lose $75, right? So 0 shirts, I don't make any, I just have to pay that setup fee, then I lose that much money right there. So this is my profit. And so we can use that equation to fill out that table and then answer those questions. So let's take a look at those. Come on, Zoom, get out of my way. All right, so we need to then figure out 0. Well, that's pretty obvious. I'm going to lose $75. And for one shirt, well, I figured out I'm making $10 per shirt overall. So that means I was down 75, I sold one shirt. That means I made $10. So now I'm only down 65 total. And if I sell another shirt, I'm up $10 again. So now I'm only down $55, right? And if I sold 10 shirts, that means, right, we sold them for 15, but we had to pay $5 for the shirt. We're making $10 per shirt. So that means I've made $100, but remember, we started off down 75. So I think that's gonna put me at 25. I better whip out a calculator to double check that. So I like my Desmos calculator. Ooh, I got the widescreen version today. That's fascinating. Oh, now I don't. Weird, okay. So let's see, our equation was if we, for our profit, 10 times the number of shirts, and the table said sell 10 shirts. And then keep in mind, we had to pay out that $75 initially. Yeah, so after selling 10 shirts, I finally have a positive profit, right? And earlier I had plugged in 2 shirts in my head and saw that after selling 2 shirts, right, I'm still in the hole based on the $75 I had to pay out up front. And I could just kind of keep replacing that 2 with a 3, a 4, a 5, a 6, 7. So at 7 shirts, I'm still in the hole. I haven't made up for that $75, but finally after 8 shirts, that covers my $75 I had to pay out to get started. And I finally made $5 whew, after selling 8 shirts. So I got to sell a bunch more because I want to make $500 at least. And this would be a great problem for a spreadsheet too. So we can whip that out in a moment. How much additional profit does the team make for each shirt they sell? So we figured out that back in our notes. We figured out that given that they sell them for 15, but they had to pay $5 per shirt, the slope here is the additional profit per shirt. So we figured out they make $10 per shirt to increase their profit. Cool, we answered that question. Calculate a linear model for their profit in terms of the number of shirts they sell. They say use P for profit and N for shirts. Okay, so again, and when you click on this, it'll say, hey, use P and N, right? So pay attention to that. So back on my notes, what did I write down? I used the word profit, so that's good. Instead, they want me to use just a P for profit. And then usually we write our MX plus B next. We figured out M was 10. They don't want me to use X, they want me to use N. And then that's not a plus, it's a minus 75. So that is my equation with the variables suggested. Always use the suggested variables. So I can click on the P or type the P. Cool. And you guys should be submitting these as you go. And if you're moved ahead, that's cool too. And then I got to pick 2 points to plot this. And again, remember, this can only use 2 points, even though we calculated more up here. So I think I'm going to go, let's see if I look at this here. Okay, I can see -75 down there. I think I'm going to plot the first point and the last point, 10, 25. And any 2 points work. It doesn't even have to be points on this table. So if you calculated some other points, that's cool too. So let's see, I have to point 0, 75, which should be about there-ish. And then 10 went with 25. Ooh, and this is skipping by 5, so that makes it easier to plot. Is that 25 right there? Always double check. 10, 25, that looks cool. And that is -75. And if you put a point in the wrong spot, you can always grab it and move it before you submit it. So always double check, look back at your table, look back at your notes. Did you really plot the right ones? Does it look like 2, -55 is on the graph? Let's go look. 2, if I trace that down, yeah, that looks like -55 there when I trace that over. Cool. Yeah, so I picked 2 points from my table, and I believe that's my line. Other things to double check, you can see the x-axis passing through here, and at 7 shirts, right, I'm still $5 down, and finally at 8 shirts, I'm $5 up. So I usually like inspect my graph a bit before I hit submit, just to make sure I did the right thing. How much money will they raise if they can sell 30 shirts? No problem, we can type 30 into our formula. How many shirts will they have to sell to raise their goal of 500? So there's a couple ways to do this. We could guess and check like I was playing around with earlier. We could solve an equation, or we could whip out a spreadsheet. We could do all 3. And it's good to have a bunch of different tools to confirm you're doing it right. Right, so I could just plug in numbers here, like what happens if they sell 100? Ooh, they make $925. Okay, I only needed 500. So what if I sold 50 shirts, 425? Oh, that's close. Now I could spend a while guessing and checking. I don't really want to do that. So I'm going to write something down, and then I'll show you a spreadsheet. Notes. So we want to get a profit of $500. And we know we have an equation for profit that's 10n minus 75. So if we just put these 2 facts together in one equation and solve, then we got it. So 500 equals 10n minus 75, or you could write it the other way. You could write it 10n minus 75. We want that to equal 500. And we did some solving equations last time. We get rid of the thing that's furthest away from the variable first on one side. So 10 is closest, -75 is farther. To get rid of a minus, I do a plus. So these disappear, right? Negative and a positive go away. Just leaves the 10x behind. Now I have 575. To get rid of a multiplication, we divide. So x should be, dividing by 10 shifts the decimal once, so I think that's going to be 57.5. Always a good idea to check on a calculator. So we'll check that in a couple of ways. First is I'm just going to plug in 57.5, and I get exactly 500. So that's definitely a check that'll work there. Otherwise, I had 575, and I divided by 10, and there's my 57.5. So I'm double checking my numbers. Quick spreadsheet on this one. Always good to advance your spreadsheet skills. Blow it up so you can see it better. All right, so really all I care about are the shirts and the profit. And since I have the profit equation, I can just use it. So I can type any numbers I want here, like 1, 2, 3, 5, 10, 50, 57, 58. First number t-shirts I sell, I'm throwing 100. And then for the profit, I'm just going to use the equation. So the equation was 10 times n, but here I can't type 10. Oh, I can type 10 times n, but the computer's going to be like, n? What the heck's n? So I have to say, oh, n is whatever number is next to you right there, and then minus 75. And once I type that kind of equation once, enter, the computer says, hey, you want to fill that down? Sure. If you're using Excel and your computer didn't fill that down for you, you can do it yourself by clicking back on the formula, pointing to that bottom right corner, right? So it's multiple steps. Type the formula, click back on the formula, then point to that bottom right corner so you get the plus icon, and then drag that down and it'll do a bunch of calculations for you. All right, so here's some numbers I saw earlier, right? And then I can see that at 57, selling 57 t-shirts, I'm at 495. At 58 t-shirts, I'm at 505. I can't sell 57 and a half t-shirts. Well, I could, right? I could make somebody a crop top maybe, but I'm still going to charge them 15 bucks for it, so that doesn't really count. So I would say to meet the goal of $500, you would have to sell 58 shirts. 57 doesn't quite cut it. Let's read the question again, see how we should answer that. So question number 9, how many shirts will they have to sell to raise their goal of $500? And again, this is a t-shirt. I'm not going to sell half a t-shirt. It says I could type a decimal there, but I'm going to type 58. That's what I'm going to submit. Yeehaw, I got it right. I wonder, would it take 57.5? Sometimes I like to play with my homework and see what happens. Oh, it didn't like that. Why not? That's the right answer. Does it make sense to sell half a t-shirt? Oh, fine, it doesn't. All right, 58 it is. Cool. And I lost a point messing around. Oh, well, I still have other points. It's okay. All right, so hopefully that made sense. I'm going to set up the next problem and then set you guys free to work on it on your own, and feel free to ask questions if you got some. All right, so this is the latte problem. So this one's a little tricky because I got some details to think about. So I'm going to take a screenshot, pick it apart. And again, when I'm solving math problems, if I just look at it and think without writing stuff down, I'm going to do a crap job solving it. I'm not going to do well. To do a good job solving it, come on, where's my screen share button? There it is. And I want all of that, I guess. And there we go. I need to write stuff down. And writing stuff down does a couple things for you. It helps you process what's going on. And 2, you can look back at what you wrote and think about it if it makes sense. It's hard to look back at your thoughts. What did I really think a few minutes ago? I'm not exactly sure. It was something along these lines. All right, so write stuff down, write stuff down, write stuff down. And if you forget, write more stuff down. All right, local coffee shop offers a coffee card. You can preload with any amount of money. Cool. And use it like a debit card to purchase your coffee. At the beginning of the month, when you get your paycheck, you load it with 50 bucks. So we're starting with 50 bucks. All right, and then each day, your short soy latte, interesting, costs $2.63. I actually prefer coconut milk or oat milk, but that's all right. We'll go for it. Okay, so each day it costs that. Okay, so here's what I'm thinking. I'm thinking the 50, that's my starting value, right? We're starting with 50 bucks. So that's like our B, our y-intercept. And then the cost each day, that's a per day thing. That's got to be my slope. So the trick in these problems is looking at them and saying, okay, which numbers here represent slope type numbers, which numbers are like starting points. So I think that's my M. And I'm paying out for that. So my M is a negative 2.63. So if I just think about the whole y equals mx plus b thing, where y is the money on my card, money on card, and x is the number of lattes per day, I guess I'm only getting one a day, so I guess I'll consider those days. I got to read the problem to double check. I think my equation would be y equals negative 2.63 times X lattes or X days, assuming I get one a day, starting with $50, right? So each time I get a latte or each day, I get 263 taken off my card. All right, so that's to start. Let's see what the book or the homework says. And the homework is the book, by the way. Estimate if the coffee card will last till the end of the month. Every weekday. Oh, I'm not getting them on weekends. I guess I get to sleep in on weekends. Cool. All right. Estimate. Let's make a guess. All right. So 260 is like 250. So 2 days would be $5 every 2 days. And how many weekdays? There's like 4 weeks in a month. 4 times 5 is 20. Every 2 days would be 10. So actually, I got to write that down. That was too much in my head. All right, let's estimate. Here's my notebook. Here's my notebook. Estimate. Month of weekdays. All right, so there's like 4 weeks in a month. And there's 5 weekdays per week. So then that gives us a rough estimate. Those two together would be 20 weekdays per month. I was thinking that 263 is around 250. So that would be like $5 every 2 days. Per 2 days. How many groups of 2 are in 20? There would be 10. 5 times 10 is 50. Yeah, I'm thinking this will, oh, but then this is more than 250, so might not make it. I underestimated that 250 per day, because 250 plus 250 is $5, seemed nice to me. So 250 per day, I would make it. If there's more than 20 weekdays, I won't. And if they cost more than 250, I don't think I'm gonna make it. So I'm thinking, nah, this is pretty close. I don't think we're gonna make it. Might not make it the whole month, unless it's like February. Might not make it. All right, so it's just a guess. I don't know, I didn't actually do the real math. No, I think it'll run out. But maybe you have a different opinion because you did more detail than I did. That was my rough sketch there. All right, if you purchase a latte every weekday, create a formula for a linear model for the balance B. Okay, so they want me to use B, not Y. B, which I could type or click. And then T is a weekday. So every weekday we lose that 263. So B equals minus 2.63. T, good idea to click it so you don't mistype it, starting with 50. All right, so I'm gonna stop here. I'm gonna let you finish up that, and then that's the end of this. Then we'll look at some homework and the next week.